I'll read this just for the sake of reading it. But one application of linear equations is the concept of the relationship being between the distance traveled and the rate of travel and the time traveled. If you assume that the rate is a constant, the relationship becomes this formula: distance equals rate times time. As letters, it'd be d equals rt, or just some people just say it's dirt. I don't really care one way or the other, but d equals rt like this. Now, I actually prefer to look at this in terms of rate, right? Like if you were to solve for rate, you'd divide both sides by time, just like we did with those literal equations. Then the t cancels. And I like to see it in more terms of the rate, and it doesn't matter if it's lowercase or uppercase, but distance divided by time. Okay, so the only reason I did that right there is just so we can see a couple different formulas. But I don't even think about it in terms of the formula because, well, I drive a lot, so when I think about a rate, I think distance divided by time, because when you drive, you're generally looking at miles per hour, and as a fraction that shows as miles divided by hours. Okay, so I know miles is distance, hours is time, so I would know exactly where to put those two in the purple formula that I made right there. Let's continue with this though before I get on too big of a tangent. So to estimate our average speed, or the rate from home to either school or work, we're going to do the following. Estimate the distance in miles you travel from home to either school or work. So you don't have to use the school, whatever is more convenient for you guys. Now, for me, if I'm traveling to Slick, even from my other job, right, it's still about 40 miles. Okay, so I'm going to use 40. You can use whatever you want, though. And generally speaking, it usually takes me 50 minutes, but I'll say 45 in this case because it's going to give me 3/4 of an hour, which as a decimal is 0.75, okay? And I don't really care which one you put. The decimal, I think, is going to make the calculation easier, though. Now, it says the rate equals, I'm sorry, I shouldn't read C, right? So using the distance formula given above and your estimates in A and B, calculate your estimated average speed. Round the answer to the nearest tenth if necessary. Now again, I would just look at this. I know it's miles per hour, and right up there, I know it was 40 miles in 0.75 hours. So it's 40 divided by 0.75. Again, you're just taking your miles and dividing it by whatever the time it is for you. So 40 divided by 0.75, I don't know what that is. Pushed the wrong button. My calculator. 40 divided by 0.75 is 53. It's a pretty ugly decimal. 53.3 repeating. But it did say it around the nearest tenth. So it's just going to be 3. And again, that's in miles per hour. So that's my answer for part C here. If you needed to get there in 0.8 hours, that's 48 minutes, how fast would you have to go using your estimated distance from A? Calculate the average speed you'd need to go. Well, I guess I didn't need that specific part, but I do know or remember that I'm 40 miles out from the campus, and I'm going to divide it now by the amount of time it looks like it would want me to take, which is 0.8 now. So when I calculate this, again, and we should know that it's miles per hour because this is in miles per hour. Okay, so typing in the calculator, 40 divided by 0.8 equals 50. That's right on the money for me. 50 miles per hour. So again, for you, on this specific problem, the 0.8 is going to remain the same because for all of us it's saying, well, how fast would you have to drive for it to be that 48 minutes? It's this number that's going to change for you, whether you're 10 miles away from campus or 80 miles or whatever. And again, the direction doesn't even matter on that either. Next up, if you were traveling 33 miles per hour, how long would it take? Use your estimated distance from A, calculate your time in hours, round it to the nearest hundredth, it looks like on this one, and we'll write the result in the equation, write the equation and solve for T. Okay, well, here we go. So this one, it wants to know how long would it take. That's T. Well, I can go back to the original. equals the rate times the time. But this one, we want to know the time. And they gave us a rate already, which was the 33 miles per hour right there. It's 33. So I got 33t. And again, my distance, not that it's yours, but for me it's 40. All right. So again, this just becomes a one-step equation that I need to solve. Divide both sides by 33, which is 1t now. So in my calculator, 40 divided by 33, it gives me 1.212, and it did say it around the nearest hundredth, so I'm going to keep that as 1.21 hours. That's a long time to drive. It's taken me longer to get to the campus before, just depending on snow and traffic and the knuckleheads, you know what I'm saying?